Here we go. Our objective for today, I can summarize data and compute the measures of central tendency. Let's read together. 1, 2, 3. I can summarize data and compute the measures of central tendency. Let's read again. 1, 2, 3.
I can summarize data and compute the measures of central tendency.
And if you notice, we already started this last week. Is that correct? All right, and last week we just focused on the measures of central tendency. So think about it. Which are the measures? Tell your neighbor, please. Which are the measures of central tendency? That is correct. Everyone? Mean, median, and mode. So the range is not part of, and I clarified that when we did the FAIR model. Remember that? We said the mean, median, and mode are the measure of central tendency. The range was not, but we were going to be finding the range. Is that correct? So from there, we had some definitions. We did not need to write those down. We actually worked those out. Remember that? We wrote steps 1 and 2 of the process, which was organize data from least to greatest and identify mean, median, and mode, and range. So for today, we're going to be working on steps 3, 4, and 5. Copy those, please. Identify the upper and the lower quartile. Step 4, identify the standard deviation. And step 5, summarize, which is analyze and compare. Copy that, please. All right, let's see. So once again, we already know how to organize data from least to greatest, find the mean, median, mode, and range, identify the upper and lower quartile, identify standard deviation, summarize. So the last 3 steps are what we're going to be working on today, okay? So just to revisit the first 2 steps and do all this process together, I'm going to ask you to copy the following problem, and we're going to do steps 1, 2, and 3 for that. Copy this, please. It says, example 1A, find mean, median, mode, and range of the data set 4, 7, 8, 2, 1, 2, 4, 2. You don't need to copy the instructions, just copy the data set. You're welcome. So what would be our step 1, Voss? It's already in order. Oh, from least to greatest. All right. So we start with 1, 2, 2, 2, 4, 4, 7, 8. All right. So from least to greatest, there it is. All right. So from there, let's identify the fastest one, which is the mode. And what is that, Jocelyn? 2. The median. How do we find the median for this data, Chris R.? Going towards the middle, but we have 8 numbers, so therefore we have 4 here and 4 here. So do we have a number in the middle? Add 2 of the numbers. Which ones? Add 4 and 2, so 2 plus 4. And then divide by 2. That's how you find your median here. So this is 6 divided by 2, which is 3. So let's label that right here. And we're going to label this one Q2. Yes. Can you just find the what? Yeah. That's how you find it. Because sometimes if they give you that, let's say this number is a 7, then you need to add 2 plus 7 divided by 2. So, all right. So let's find our mean. Can you elaborate? How do we find our mean for this data? Go ahead, Idalis. Add up all the numbers and then divide how many numbers they are. So what is the sum? Very good. 30 divided by 8. Hands, have you got 30? Okay, good. So 30 divided by 8, and that is, everyone? 3.75. That's our mean. Okay. And the last piece that we're going to find is the range. And how do we find the range for that, CBES? The biggest number is 8. So what do? Subtracted by the smallest, so therefore this is 7. Thank you. So the range is 7. So, now that we're done with that, step 3 says identify the lower quartile and the upper quartile. So this is what we do. Look up, please, pens down. So now that we have it up to right there, I'm going to focus right now on the lower portion of the data. How do I know it's the lower? Because I'm going to go by the median. Here's a median. The lower part of that median, that's the lower portion, and this is the upper portion. Right now I'm focusing on these. By looking at these, what is our median of these 4 scores? Everyone? 2. So Q1 is 2. With that same idea, let's look at the upper half and tell your neighbor what would be Q3 for this data up here. Patrick, go. Patrick said Q3 is 5.5. Hands if you agree with that. How did you find that, Patrick? So you can let everybody know. You added 4 and 7. Why 4 and 7? The 2 closest to the middle, we're finding what? The median of these 4. Since there's no middle number, he added 4 and 7 divided by 2, and that's how he got 5.5. Yes? Okay. So once again, Q1, Q2, and Q3. So I'm going to give you the next data set. I want you to find me again mean, median, mode, range, and then I want you to find me Q1, 2, and 3. Here it goes. Copy these. And on this one, once again, you don't have to write the instructions. It's the same instructions as the previous one. The data set that they give us is 6, 4, 3, 5, 2, 5, 1, 8. Copy that. See if you can do that one by yourself. Go. All right, so first step, setting that in order. Give me that order, please, Jonathan. One, 2, 3, 4, 5, 5, 6, 8. All right. So, pass to someone. Mode. Pass to someone. Median. Mia. 4.5, also known as what, Mia? Q2, 4.5. Thank you. Pass it to someone. Mean. Okay. Come back to you. Range. Angel. 7. All right. And then from there we go to Q1. Has someone, Angel? Q1 2.5. That is correct. Pass to someone. Q3. Erica. Q3 5.5. And we're just waiting for the mean. You know what I mean?
Oh.
4.25. Hands if you got that. That is correct. Okay. So, any questions with this so far? Okay, let's move on to funner stuff. So, today we're going to cover something that we call standard deviation. What's it called? Let me show you the symbol for that. Look up, please. The symbol for standard deviation is like this. Look up, please. They use like a 0, but with a little hat, like this. That's a symbol. Okay. No, it's a 0 with a hat. Okay. So anyways, it's going to look like this. The formula for finding the standard deviation is as follows. Standard deviation is taking the square root of the sum of all the means of the squared of the difference of the means and the data set. You're like, that's a lot of stuff to remember. Yeah, don't remember it. Don't write it down. What I want you to write down is this next example. Write down example number 3A. And it says, calculate the standard deviation for the temperature data for the month of April. April high temperatures were 77, 86, 84, 93, 90. I doubt a focus. You're not writing. Once you're done with that, underneath that, I want you to copy this table. It gives you a column that says data value, and they label it X. The next column is called deviation from mean, which is X minus the mean. And the mean, they use X with a little sub bar on top. And then the third column is squared deviation. Okay? So, copy that, please, and then we'll go over it. All right? So let's see. Standard deviation. Those two terms by themselves are fairly simple to understand. If I say standard, it means that it's something that's average, something that it's average or common. If I say deviation, the word deviation comes from the word deviate, which means that it's away from. It's away from. So if I send somebody to the restroom, or they come and ask me, Mr. Q, can I go to the restroom? Sure. I give them the pass to the restroom. And instead of going to the restroom, they go to the lockers. They deviated from their path, right? Instead of going there, they went elsewhere. So it's away from. So today I'm going to show you how to take a set of data and find out what the standard deviation. Standard deviation is how close are all those numbers to a specific distance away from the mean of the entire data. So watch. So step one is always like step one. What is our step one, everyone? Organize the from. So let's do that here on this column. So the first number is 77. 84, 86, 90, and 93. Pardon my writing, it's not me, it's the tablet. I don't know what's going on. It's like unplugging itself every now and then, so be nice. Next, what does it say in the next column? Look up, please. It says that we're going to subtract, oh, by the way, all these are x values. Is that correct? Next column says subtract the x value from the what? Mean. Do you guys know how to find the mean using these numbers? What do we need to do? Talk it over with your neighbors. What do you need to do with those? How do we find the mean? Add them all and divide by the number, which is 5, and that's how we find our mean. So let's see. Add those up, please. Find me the sum. Gianna, what'd you get? What's the sum? I'm sorry? No? What'd you get for the sum, boss? 430. And when we divide by 5, what is our mean, Francisco? $86. All right. So notice here the last part of this column is going to be 86. 86. Well, doesn't it say to use that for each of one of these? 86. 86. And we're going to subtract the x values. What is my x value for this one? 77, 84, 86, 90, and 93. So look up really quick. If you notice, this is the same thing as this. Is that correct? So I'm going to use the difference, and I'm going to write it here in a parentheses squared. So what is the difference between 77 and 86? -9. Difference between 84 and 86? -2. Between 86 and 86? 0. 90 and 86? 4. And 93 and 86? 7 squared. So, let's find the square deviation. Let's see. All right. -9 squared is 81. Next. 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 And, all right. So now, what do we do with these numbers? What we do with those numbers, we're going to find the mean again, and that mean now is called the squared deviation. Very good. So this, we're going to find the mean. How do we find the mean again? We find the sum and then divide by how many numbers there are. How many numbers are there? 5. So find me the sum first so I can write it in there. What's the sum, my Dallas? My goodness. Very good. 150. B9. So our square deviation, or our mean of this data here, 150 divided by 5, that's 30. Okay. However, what are we trying to calculate here? What did it say? The standard deviation. This one is squared standard deviation. How do we cancel that squared? square root, and that's how we're going to find our standard deviation. So find me approximately what square root of 30 is, please. You already know how to do that. Go. All right. Okay, what's our standard deviation? Janice, what'd you get for your standard deviation? 5.40 what? 45 repeating. Hands if you got that. That is correct. Now, if I was to round it to the nearest tenth, just to be, because I'm going to show you how to use the standard deviation so you understand what it does. It would be, standard deviation would be approximately plus minus 5.5. Are we there? Okay. So now let me show you what this does. Let me go a little bit to the right. Follow along, please. I want you to draw a number line. Nice and straight like mine. All right. So check this out. What was our first data that we have? 77. That's going to be our first number. 77. 78. 79. 80. 81. 82. 83. 84. 85. 86. 87. 88. 89. 90, 91, 92, 93, 94, 95. All right. So let's start off with the first piece of information that we got from this whole thing. What was the first piece of information that we got? The mean, which was the X with a little bar, right? What was it? 86. So watch. I'm going to mark 86 right here. 85, 86 is about right here. And that is our mean. Okay? Now, standard deviation says that the distance from that mean is how much apart? How much? 5.5 plus minus, right? So if we go 86 plus 5.5, what does that give us? 91.5 is about right here. Put a little dotted line right here. And this is our standard deviation 1. So that was plus, but how about minus? What is 86 minus 5.5? 80.5. 80.5 is about right here. This is standard deviation 1. Okay. Well, yeah, what is 80.5 plus 5.5? Okay. So if I go one more standard deviation from this one's at what? 91.5? So what is one more standard deviation? 91.5 plus 5.5, what does that give us? Very good, 97. 97. And what would we label this standard deviation? What would we label it? Standard deviation 2. Very good. So if we are at 80.5 minus 5.5, what does that leave us? 75. Thank you, Dylan. 75. And we're going to label this standard deviation 2. So if you notice, it does what? It separates the data into different quadrants. Does everybody see that? Now, what does this do? Well, it just shows us where the data falls. The first data they gave us was 77 is right here. What is the next one? 84 is about right here. The next one is 86. It's right there. The next one is 90, which is right here. And the last one is 93, which is over here. So according to what you see, what can you concur? Or what can you, what would be an observation? That most of the data falls between what? Standard deviation what? Number 1. Does everybody see that? Most of it is right here. Okay? So how is that information like helping us? That shows us that most of the data or the patterns that we need to look for have to be in this section right here. Now, an application for you guys, and this is really going to come up when you get to college, who's heard of grading on the curve? When you get to college, some professors, instead of using, you know how we use, as teachers, we use, okay, you get an A+ if you get 97% and greater, right? And then the next and the next. So watch. Look at this. Okay, I'll wait. Look at this next section. If you notice here, most of the data is here. But then there's a high score right here, 93. And as a professor, I would say, you know what? Since most of the students scored here, to help them out, I'm not going to count this one. And I'm only going to count with the highest score of this section. What was the highest score? 90, and that's what they call grading on the curve. So their A+ will be now what? The A- will be an A+. And that's why they're grading it, because it's closer to the mean of the class. Okay? So now, home play for tonight. You kept the other day the home play. Hold on, let me show you, because it's going to be on the video also. This one, and this one. Is that correct? Okay. You kept that. You just turned it in the Nearpod, right? So guess what? You need to find me on this one Q1, Q2, Q3, and standard deviation for 3. Yes? Have a good one, guys. Enjoy your home play. There's tutoring today. If I don't see you, or if you want to stop and say, hey, by the way. Anyway, bye. Have a good one.